In this problem, we have to design a fillet weld to connect the plates which are overlapping, that is one placed over the other. We are asked to design it so that it could transmit a pull which is equal to the full capacity of the smaller plate. We are given that the thickness of the plates is 12 mm and the grades of the plates is 410. Also, we are told that the welding is done in a workshop. Now, we know that the minimum size of a weld, it depends upon the thickness of the plates. So for plates which are from 10 mm to 20 mm, the minimum size should be 5 mm. Also, we know that the maximum size of the weld should not exceed the thickness minus 1.5 mm. So the thickness is 12 and 1.5, 10.5 mm. Let us adopt the size of the weld as 10 mm. So small s is 10 mm. The data given to us, Fy will be, sorry, this is not Fy, but this is Fu. Fu is 410 Newton per mm square. Gamma Mw is 1.25 for shop welds. Thickness of the plate is 12 mm and the breadth of the plate, okay, now we are talking about the smaller plate, is 100 mm. We have to find out the full capacity of the smaller plate. So the full design strength of smaller plate is given by Ag Fy upon gamma M0. Fy is the yield strength, which is 250 Newton per mm square, and gamma M0 in this case is 1.1. So substituting, gross area would be the thickness into the width. Fy is 250 and divided by 1.1. This is equal to 272,727 Newton. So that means we have to design the fillet weld to take this much of force. Now let L suffix W be the effective length of the weld. We are assuming a normal weld. We know that the value of K depends upon the angle that the two plates make with each other. Now in this case we have not been told what angle it makes, so we are assuming normal welds. So the value of K will be 0.7. T is to be taken as K into S, so 0.7 into 10, which is 7 mm. Therefore, the design strength of the weld is given by the area of the weld, which is given by LW into T, into Fu upon root 3 upon 1.25. LW is what we need to find out, substituting the other values. This has to be equated to equation 1. So we say LW into 7 into 410 upon root 3 into 1 upon 1.25 equals to 272727. From here we get LW as 205.7 mm. So we can say provide effective length of 105 mm on each side. So 105 plus 105 will give us 210, which is slightly more than 205 that we require. So this is how we are going to provide it. So 105 mm on this side and 105 mm on this side, which will come to 210 mm total. This solves our problem. We were asked to design the weld, fillet weld, and we have to find out the length, which we have found out. Thank you.